Hello, ladies and gentlemen. Today we will be doing question 1. Oh, crap. Today we'll be doing question 1 from the 2016 FRQ AP Calc AB test, which gives us a nice little paragraph. So read that little paragraph. Important things say, like water's pumped into a tank at this rate. So knowing that this is a rate is mega important. So I like to circle the word rate, and I like to underline into, so I know that that's what's going into the tank. Liters per hour for 0 to 8 hours, where T is measured in hours, blah, blah. Water's removed. Okay, so removed from the tank at a rate modeled by R of T, which is up here. So this R of T represents the rate removed. So a little text marking goes a long way. All right, keep reading. R is differentiable and decreasing. So the fact that it's differentiable means that it's not just differentiable, but also continuous, right? Because differentiability implies continuity. So it's also continuous. And decreasing on that interval. Selected values of RT are shown in the table above. At time t equals 0, there are, so this is like our starting amount. That's how much water we start with. Starting amount. So there's some good things to text mark before we even start working on the problem. All right, question number A says estimate R prime of T. R prime of 2. I promise I can read sometimes. So to approximate R prime from a table, we're going to look at the slopes between the 2 points. And since 2 is between 1 and 3, we're going to look at the slope, the rate of change between 1 and 3. So we're going to check out what would be my slope at 2. So to do that, I need to say, hey, it's like R of 3 minus R of 1 all over 3 minus 1. That's our slope formula, or your slope of secant line formula from back in the day, like the first month of school. Alrighty, and what we're trying to find is R prime of 2, and that's going to give us our approximation there. Cool. So let's throw some values in here. R of 3 is totes 950. And R of 1 is 1190 over 3 minus 1. Do the math, and you get negative 120. This is a calculator question. It's question number 1, so it is a calculator question. Liters, it says indicate units of measure. So since it's the derivative, it's the rate of change of R, that means it's going to be liters per hour, or liters per hour squared. Cool. So there's a happy answer for number A. Moving on to B, it says use a left Riemann sum with 4 sub... Excuse me, Roshan. I apologize for that interruption. Number B says use a left Riemann sum with 4 subintervals indicated by the table to estimate the total amount of water removed from the tank during the 8 hours. Is it an over or under estimate? All right, so let's do it. So part B asks for a Riemann sum, a left Riemann sum. So that means making a left Riemann sum, I will use this point, but I won't use the rightmost point. So remember, a left Riemann sum will be the area of these rectangles, where the base of the rectangle is your change of x, and the height of your rectangle is found by the left vertex of that rectangle. So our first rectangle is going to have a base of 1 because our change of x was 1, and we use that left point there to get our height, which is 1340. Our next rectangle is going to have a base of 2 and a height of, we use the left point, 1190. Our next rectangle will have a base of 3 and a height of 950. And our fourth rectangle will have a base of 2 and a height of 740. And 700 never gets used. This is a calculator question, so you should add all these together, and when you do, you get... So yesterday was Carlton's birthday. What'd you do for your birthday, Carlton?
Yeah, today's my birthday.
Today's his birthday. What'd you... All right, so adding all these together, I get 80, 50, and it's an amount, right? So it would be liters. And they ask if it's an over or under estimate. Now, since this function is decreasing, even if you forget the rule, I'm just going to sketch a little decreasing function. And since I did a left sum on a decreasing function, it's totes an overestimate. Overestimate, I don't know how to spell estimate. And the reason, because the function is decreasing, because R of t is decreasing. Alrighty, cool. Number C. Use your answer from part B to find an estimate for the total amount. All right, this is the big money question here. Find the total amount of water in the tank at the end of the 8 hours. All right, so whenever we do this question, we need to understand everything that's going on with this tank. We started with a certain amount of water in this tank. So we need to understand that our total amount is going to be what we started with. We're also we're pumping water into a tank, plus what we add, plus what we pump into, I guess, I don't know. What we pump into, and then minus what's being removed. Okay, so we're trying to find our total amount. And we know that we started with 550,000. That is a number because I said it was. Gosh. And now let's think about what we're adding into this. We're adding into at a rate of WT. So how do I go backwards from that rate to get the amount that we've added into it? So to go backwards from a rate to an amount, we're totes going to use the integral. Yes, that's beautiful. From 0 to, we're going 8 hours. 0 to 8. I'm going to need a calculator soon. Luckily, I have one right here. All right, minus what's removed. Now, in the last problem, we made an estimate for how much is removed in those 8 hours. So I'm going to use that estimate in this problem. So after doing some work in my handy-dandy calculator, I found out that the total amount is 50,000 plus, and the amount that we've added into the tank according to this integral is going to be 7,836.195 minus 8050. And let's add all those together. And it looks like all this adds up to be 49,786.195 liters after the 8 hours. Cool, and this is to the nearest liter, so I don't even need the decimals. Nice, so that is my final answer for C. And lastly, we're on to part D. All right, for this last. All righty, on to number D. Oh. For number D, we're gonna compare the rates that are going into the tank and out of the tank, and I'm gonna write a function to represent that. We'll call it A of T. A of T is in memory of Amber Williams. Oh man, I feel really bad if that were one day true. So A of T is what we're gonna call it, just to call it something. And that's going to be the rate at which water is coming in and going out. So A of T is going to be our water coming in, which is WT, and water going out, which was R of T. So,
Can you just find a place where they're equal to each other?
exactly, because if they were equal to each other, like my friend Jared said, then this would equal 0. Now, my good friend Dominic is saying I should graph it and see when that's going to happen, but I don't think Dominic realized that we don't.
You can still plot certain points and get the graph to do it itself.
Dominic's got some great ideas. We could totally plot those points and do it on our calculator. That is also true. He's a smart man. Cool. What I'm going to do is I'm going to see if there's a place where W of T minus R of T equals 0, where the rate going in, the rate coming out are the same, so there's no water coming or going. Cool. So to do that, I'm going to analyze what's going on with my Amber function at 0. So let's look at W of 0 minus R of 0. So what is the rate at which water's going in at 0 hours? So let's look at that rate at 0 hours, W of T. Throw a 0 in there for 0 hours, and how much water is going into my tank at 0 hours? That's 20,000 times E. When I throw a 0 in there, it's E to the 0 power, which is 1. So it ends up being 20,000, or sorry, 2,000. Put my, too many zeros. 2,000 minus R of 0. Now here's my R function in the table, and R of 0 is 1340.
It's just IVT on steroids.
It is IVT on enhancement creams. Yeah, that probably needs to be edited out. So I don't even feel like doing the math. I know that that's going to be a positive number, right? Now let's look at what's going on at the end of our time at our Amber function, which represents the water going in and coming out, at 8 hours. At 8 hours, I've got to plug that in my calculator, so give me a second to do that. Alrighty, after plugging that into my calculator, W of 8 was 81.5. Oops. Messed up. 81.5. And then R of 8 is on our table up here. R of 8 was 700. And that's totally going to be a negative number. I don't feel like doing the math, but I know that's going to be less than 0. So class, if A of 0 is greater than 0 and A of 8 is less than 0, do you think there's going to be some place between 0 and 8 where we have a 0? Why do you think that?
Because it has to change from positive.
It's got to change from positive to negative at some point, and Justin said that's called the
Intermediate value theorem.
There you go. You know it. So that's by IVT. Now, whenever you're answering this question, you have to say why you're allowed to use IVT. So the hypothesis of IVT says that our function has to be continuous. Is our function continuous? Continuous. So because A of t is continuous, on 0 to 8.
Wait, can you just make new functions and refer to them in your answer?
Why not? IVT guarantees, totally running out of room here, guarantees What does it guarantee? That we will have a value of 0, or let's just say where a of t equals 0 between 0 and 8 hours. Which means W of t will be equal to R of t. Smiley face, the end.